So this lesson is on algebraic proofs. Pretty much what you're doing in this lesson is you're solving, but every time you solve, you're going to justify your step and getting preparation for proofs for later on. I'm actually going to have you set this up with what we call a two-column proof. So on this side would be statements, and this side here would be reasons. So we're going to start with the first one, which is 3 times x minus 4 equals 12. And that is just given to us. So what are we going to do first? Well, let's go ahead and distribute. So if we distribute, we get 3x minus 12 equals 12. So what did we do? We did the distributive property. And now we're going to go ahead and add 12 to both sides. So 3x, when we add that 12, would go away here. 12 plus 12 is 24. So what did we do? We did the addition property. Now we would divide both sides here by 3. So when we do that, x is 8. What do we do? That is the division property. All right, let's try another one. In this example, I'm going to do things just a little differently so you can see some other properties come out. We've got statements. We got reasons. And we're going to start with number 1, which would be 6x plus 2 equals 8x minus 9, and that was given to us. Now what I would do is subtract 6x from both sides. So 2 is equal to 2x minus 9 when I subtract it from both sides. So that right there, we use the subtraction property. Then I'd add 9 to both sides here, so then I would have 11 equals 2x. So what did we use? We used the addition property. Then I would divide both sides here by 2. So I would have 11 divided by 2, or 11 halves, equals x. So that right there is called the division property. And finally, just to make sure we're consistent, we're going to switch sides here. So x equals 11 halves. When these two on the sides are not the exact same thing, but it's representing, in other words, x is being represented by 11 halves, that is called the symmetric property. All these properties that we were just using are of equality. So if this was x equals x, that's like the reflexive property, but when we're switching this and these are two separate entities or two separate pieces that are representing each other, we call that the symmetric property.